In today's video, we're going to look at how to find the probability of compound events. So again, to talk about what a compound event is, it's when there is more than one possible outcome. So in simple events, there was only one. In compound, more than one. So there are two types of compound probabilities. There's independent and dependent. Today's video is over independent probability. Probability looks like, we're going to show with a word problem first and then go into some skill applications. We have here that the picture represents a dresser drawer of socks. What's the probability that you will choose a red sock, replace it, then choose a black sock? So if we look at this problem right here, we have 1, 2, 3, 4 blue socks, 2 red socks, 3 black socks, and 3 white socks. So there are a total of 12 socks altogether. If you were to stick your hand in your dresser drawer and pull out a red sock, you have 2 chances of pulling out of a red sock out of 12 total socks. You put it back. When you put it back, the total does not change. So there's still that total of 12 in the second option. They then want to know the probability of a black sock. So there are 3 black socks out of 12 still because you put back the original red sock. So what we have here now, when we deal with independent probability and 2 compound events, we always multiply them together. So we never add, we never subtract, never divide. It is always multiplication. So I'm going to write that really big because that is the huge point about compound probability. We multiply it. So when we look here, we have 12 or 2 twelfths times 3 twelfths. Both of those can reduce down to nice pretty numbers, so I'm going to reduce those down. This reduces down to 1/6 times 1/4. Again, the common factor here was 2, so when we divide by 2, we get 1/6. Common factor here was 3, so we get 1/4. When we multiply that out, we get 1/24. So the probability of both of these events occurring, the probability of picking a red sock on the first go, putting it back, and the probability of picking a black sock on the second go is 1 out of 24. Since the first sock was replaced, choosing a red sock on the first try had no effect on the probability of choosing a black sock on the second try. That is the definition of what an independent probability event is. That is, when the 2 events, we're going to call them event A and event B, are independent if A does not affect the probability of B. So this is just right here, it's just kind of a fancy-ish way to write that. You really kind of just need to know the big part of this. If you ever see the word and, it is always a multiplication word. Just like or means add, or you can see the multiplication sign right here. So then to practice problems like the sock problem, or we can see things where it's just 2 simple events. We have a spinner and we have a die. This spinner has 1, 2, 3, 4, 5, 6, 7, 8 total sections. And dice, remember, dice always have 6. So these 2 events will never affect each other. I can spin the spinner all day long if I wanted to, and roll the die all day long if I wanted to. The outcomes of the spinner will never affect the outcomes of the die. So these are going to be independent when there are 2 separate events that can function all on their own. So they want to know the probability of spinning a red. So if we look, there are 3 red sections out of a total of 8. And the probability of rolling a spinner. So if we look again, here's this big word and we know this word means to multiply. So here, the probability, the probability of rolling a 5 is 1 out of 6, so remember it means multiply. I can cross simplify on this one. The 3 and the 6 have a common factor of 3. 3 goes into 3 one time, and into 6 twice. So when I finish this out, I have a 1/16th chance of spinning a red and then rolling a 5. We have the probability, what they want to know, a probability of rolling a 5, then rolling an even number. So again, we have die number 1 and die number 2. Neither of those dies affect each other. The first die I can roll to my heart's content, and it will never ever take away a number from the second die. Think of it this way. If I were to roll a 5, indeed, on that first one, so remember that is a 1/6 probability, just because I roll a 5 on that die does not magically erase the 5 from the other die. So if nothing changes about the second one, it is indeed an independent probability. So I will multiply and then want to find an even number on the second die. There are 3 even numbers out of 6. So I can reduce this one fraction down to 1/2 and then multiply and get 1/12 as the probability of rolling a 5 on the first die and then rolling an even number on the second die. So again, remember, independent probability does not change the outcome of the second event. So when I replace stuff, put stuff back, or one event is its own self, then it is an independent probability.